function notation and evaluating that function. Now we already know something like this linear equation here is a function, but we're going to go ahead and put it in function notation. So y equals 2 times x plus 7, function notation, remember what it just does, is a different way of listing our output. So our output is y, so instead of writing it as y equals, we write it as a function of x, or we just simply say f of x. And then our relationship between x and our outputs is, to get an output, you do 2 times x plus 7. So x is the input, f of x is the output. So function notation is specifically useful for finding the values in the range that correspond to a certain domain of the value. So if we wanted to find f of negative 3, I would do every place there's an x, I'm going to replace it with that negative 3. 2 times negative 3 plus 7 is equal to 1. So f of negative 3 equals 1. A little bit of practice. Okay, so up here I have f of x, but over here I have g of x. That's because f of x isn't the only way to write function notation. So most commonly you're going to see stuff like this, those types of letters. But they all mean the same thing. So if I said f of negative 9, I want to use this rule because it says f of x. So I would go ahead and say f of negative 9 is negative 5 times negative 9 minus 14, which makes 45 minus 14, which is 31. If I wanted to do g of negative 7, I would go ahead and every place I see an x, I'm going to replace it with negative 7 in the function g of x. So g of negative 7 would be the opposite of negative 7 squared plus 9 times negative 7 minus 1. So negative 7 squared is 49, but the opposite of that is negative 49. 9 times negative 7 is negative 63, and then I go ahead and simplify. Negative 49 minus 63 is negative 112. Negative 112 minus 1 would be negative 113. So on problems like number 5 and number 6, there's a little bit extra to do. So for example, on number 5, it's saying first you do f of 1 and figure out what it is. Then, whatever you get, you're going to subtract f of negative 4. So we have negative 5 times 1 minus 14, which would be negative 19. And then we have negative 5 times negative 4 minus 14, which would be 6. And now we have to actually do negative 19, which is our f of 1, minus 6, which is our f of negative 4, and we get negative 25. To do number 6, we would just do 2 times the answer to g of 12. And g of 12 is the opposite of 12 squared plus 9 times 12 minus 1. 12 squared is 144, and the opposite of it is negative 144. 9 times 12 is 108. So negative 144 plus 108 is going to give me negative 36. Negative 36 minus 1 is negative 37. And now I need to take that answer and I'm going to multiply it by 2, which will give me negative 74. Now in a future lesson, we're going to talk about something called a composition of functions. So this is one of the basics of a composition of functions. So let's go ahead and we're going to look at number 16 to start. And it says I want to do f of c of 2. So in this one, because we're going to be substituting a expression for our variable, we're not exactly going to get an output that's a constant. So where that x was in f of x, I'm going to replace the x with that expression c plus 2. And now I'm going to follow order of operations to simplify. So I distribute the negative 4, and I combine like terms, this one and this one. So I get negative 4c plus 1. And that would be our F of CO2. Okay, now we're going to go ahead and we're going to look at number 19. And that's because number 19 is talking about g of x, and g of x is quadratic. So I'm going to do g of a minus 3 would be equal to x squared, or replacing the x with a minus 3, squaring it, and subtracting 5. So order of operations, and I'm going to do that down, this part down here, says I got to do a minus 3 times a minus 3. And if you've forgotten the shortcut for squaring a binomial, you can always use FOIL. A times a times negative 3, negative 3 times a, and negative 3 times negative 3. Combining like terms gives us a squared minus 6a plus 9. So going back to over here, I have a squared minus 6a plus 9, and then I have to do minus 5. So combining like terms, the 9 and the negative 5 make a positive 4. Thanks.